we have Peter, and Peter manages the AI for Knowledge group at IBM.
Yep.
Yes.
Exactly. So,
yeah, so they will actually give us an introduction to Docling, which we heard about in an earlier presentation. So yeah, we're looking forward to
this works. Super. Perfect.
getting to know stuff about Docling.
Yep.
I think you're ready and set up.
I'm ready and set up. Yeah.
All right.
Good.
So I think we can start 1 minute early. That's okay.
That's fine.
Thank you.
Totally easy. All right. So hello everybody. I'll be presenting Docling. I am a research manager, so lead around 20 people, roughly 15, 20 people. Depends a bit on how many students and master students come in IBM research here in Rishikon. So all the work that we're showing is pretty much done in the team here. So it's actually really a Swiss project. If you don't know where we are, so basically, this is actually the lab. So we're in Rishikon, right next to the highway, effectively. So everybody that has driven the highway has probably seen it. We are completely in the C building, all the way on the bottom there. Now the team is big and not big at the same time. So we're working. We have actually a lot of different backgrounds and a lot of different nationalities. So there's not two people with the same nationality essentially. So, but on the other hand, we're also working. Actually, we have delivered this project to the Linux Foundation. So we're working with a lot of people across the board, and we keep on actually expanding massively our collaboration. So anybody that actually uses Docling or wants to contribute, or wants to have a new feature coming in and doesn't want to contribute but wants to actually speak to us, I highly recommend just to reach out. We typically try to talk to the community and just pull that in. So that's a bit like the setting, what we do. Let me give you a bit of a thing. So what is Docling and also what is it not? So I think basically, roughly speaking, there's 3 principles that we kind of very strictly adhere to. First and foremost, it's a library. So it's a Python library, Python package, and we're not going away from that. So we're not trying to add 10,000 different things, although I might contradict myself in 3 slides, but you will see that. But the main meat, or the main thing that you should be worried about is it's basically a library. Secondary, it is open source, and it's not just open source, but with a weird license. It's open source and permissively licensed. So we have it in MIT. All the models are in Apache too. So that's actually very important. So this brings me to the third part, which is we really strive to make sure that everything can be run locally. So on a laptop or on a workbench or whatever else, so that you're not always with some annoying API that you need to get an API key and then you need to pay. And that's kind of what sets us apart with all the other libraries. They all try to kind of, give you some goodies, and then afterwards, but now you have to put your credit card in. So that's a hard no for us. So that's kind of the 3 principles. Now, having said that, of course, the 4th principle that I'm not really that should be there and that should be self-evident. That's why I don't have it as a 4th principle, is that it should be very, very easy to use. So the whole point of it is to really make your life easy with formats. So whatever you think in terms of unstructured content, how can you actually suck that up like a vacuum cleaner and return that into a structured or a uniform data structures? And that's actually what Docling does. So whether you have like audio files or PDFs or images or Word documents or HTML or whatever else, what we're basically, or Excel, we're trying to actually just be able to process that as fast as possible and as accurate as possible. For certain things that's easy, like DOCX that are programmatic. For certain things that are PDF and images, you need to do some other stuff there. So there is going to be some machine learning. So that's kind of the principles of what we adhere to. And in this way, because it's a Python library, it's typically what it ends up with is like a feature in another solution. Okay, so we're talking with 10,000 different people, people that make products, people that are enthusiasts, whatever. They all need to somehow process documents or get some specific information, and that's why they use Docling. Now, what is important is that while during the development, we basically figured out that Docling has, like, I would say, 2 modes. So when you're dealing with unstructured content in general, we see 2 modes. One is like a classical quote-unquote document conversion, which is I have my PDF here, it has tables, it has images, it has whatever else. I want to get a faithful representation. So that's what we call conversion. If it's for an audio file, it's more transcription, whatever. But actually, all the content that is there should be translated into a data structure. That typically goes into a target like for search or RAG or any variation of that one, right? So this is where that lives. There is a second part where you say, well, I actually don't really care about the content of the document. I care more about, I would like to have some very specific information out of it. So I have already my target database, say, with a target schema that has been there forever. I just want to populate the database or the rows of the database with content that would come out from this unstructured data. And so that's where we actually focus on the document extraction part. So you basically provide the schema and you say, now find me instantiations of that schema from these documents, right? So those are the two different kind of modes. And they have both their pros and cons, and they have both their applications. But that's kind of what we are facing. So I'll kind of contradict myself directly, but the reason why I want to put this slide, and I just made that slide yesterday, so it's absolutely disgusting and horrendous. But the only reason why I'm showing you that is not so much to scare you off, but there is a whole ecosystem of other tools that we actually have in the Docling organization. And quite often we see a lot of people that are actually saying, but we would like to do this. And they're like, yeah, we kind of have that. It's just not really very well discoverable. So I'm trying to already make a bit of an overview there. But as you can see, in the center is Docling, so that still remains there. And then what we typically say is, what we actually try to do with Docling is to do the conversion. So that's the workhorse, so to speak. But actually the innovation and where a lot of people can work on is actually only on the Docling core. So all the way at the top level, we actually define the data structure. And we're in the process of designing a very efficient ISO standard for that data structure. Think about PDF, but for content. And that is super light. So the whole idea is Docling has all this ML and AI, and so you get Torch and all of these type of dependencies that they are okay, but they are very heavy. And so what we're trying to do is, like, once you have it converted, you can just use actually the converted data in a very efficient way using the Docling core, and you don't worry about that. There are some helper packages like Docling parse to parse PDFs and stuff like this. And then downstream, you have a lot of, I would say, helper capabilities. Probably the easiest one is like Docling Serve or Docling MCP. I mean, I suppose you guys know what MCP is. But Docling Serve is basically a fast API wrapper around Docling so that you don't have to do that stuff to actually deploy it and have a REST API. There's some framework extensions. There's Docling SDG, so synthetic data generation. So if you're building a RAG or something like that, you might want to create like question-answer pairs on your documents, and that's basically what that does out of the box, etc., etc., etc. Docling Java is still a work in progress, but essentially the Java and the TypeScript, they are like extensions to actually have different languages for Docling core as opposed to just having it Python library. So there's a lot of other stuff there. And as you can see on the left and the right, we have the models and we have third-party models. We can run third-party models in Docling. That's absolutely not a problem. But we also have, of course, our own models. And I'll come to that one. Now, we've rolled that out. We've been quite successful so far. So, the stars are good. What is actually even more interesting is actually the community. So you can actually see here, there's a bit of a pie chart of all the people that have actually done successful PRs. So not just vibe coding PRs, but PRs that we actually included into the code. And you can see it's interesting. So we have even Apple and Microsoft. And so that's already a good section. Of course, most people are kind of unknown, or they don't really have a good trace back. But for some of them, we can actually figure it out. And that actually makes us very happy because it means that we can really grow that community, and that actually there's a good solid mass. On the other hand, we are putting a lot of Docling everywhere in all of the main or other bigger repositories so that people can very easily use it. And so this is just a small sub-selection of what we have for the ones that we found actually good logos for. So that's actually also a pretty nice thing. And so we keep actually trying to integrate Docling more and more and putting it in the places where it kind of makes sense. Now, Very quick thing of what Docling does in the most simplest case. So this is you can do this on your own laptop essentially. This is a paper. This is now not the most difficult paper, but it just shows what it is. It has figures, it has captions, it has tables. And so when you're installing Docling, of course, you can use it as the library, but we also make sure that you have a CLI that makes your life a little bit easier. It basically, you can just point it to a local PDF or a PDF on the archive or wherever else. And depending on the settings, you can get actually the figures out and you get all of the text that you want. So this is kind of really the most easiest way to use it, and then you can wrap it around. And we use it all the time. Now we have also some other visualization tools so that you can actually, put the PDF next to the actual converted document, etc., etc. And this gives us a lot of ideas of like how good actually the quality is. So we deal very well with tables, with lists, images. We're trying to deal that the captions are associated with the images, etc., etc., etc. And you can configure it in such a way to also do kind of enrichment. So you can say, I want to have also image classification or directly an image description beyond the caption, or I want to do deeper chart analysis, etc. So there is all of this functionality that is easily available. Now, then the question is still like, why are you guys doing all of this? And I do want to come back a little bit on why Docling and maybe not some other type of processing content. I don't know if you guys have seen this nice thing about the vegetative electron microscopy. Do you guys know this already? Because otherwise I skip it. But those that don't know, well, let me very quickly go. So basically, people have been starting to figure out that there are quite a few papers that have been talking about vegetative electron microscopy. There's one that is cited by 112. And this really comes because people basically, or probably OpenAI, I guess, one of the first ones that were just scraping all of the text. And if you scrape on OCR documents, sometimes the text goes across columns. And so that basically got into the training data. And I think there was just a blog coming out from Thinking Machines that said like even 250 bad documents in like trillions of tokens is enough to actually poison it. So you only have to have a very few instantiations of this thing, and you basically, it's not hallucinating, it's literally saying with the data that you provided, but it's maybe not so cool. And by the way, so if you do that with Docling, that's the whole point, that like we are not doing that. So typically what people do is they use like a PDF plumber and then they scrape stuff and they say, it's kind of good enough. Yeah, okay, good. But then you don't have that thing. Okay. Now, why is that? It's mostly because if you actually scrape the PDF is printing document format. So really it's just telling you like which character is on the page, not all. Although it looks very good, and that's why it's so popular. If you scrape, you get just this text, and so this is of course not very nice. And so that's actually one of the reasons why what we actually do in the back end is do a lot of the layout analysis. I'll come back to that one. There is another one that is actually very interesting why you should use Docling, and this is actually when you are doing like more like attacks, so adversarial attacks. So there is all of these papers now that have like this nice white text that do not highlight any negative part of the paper. So if you then just grab the paper and just put it in ChatGPT or in Claude to give a review because you are short on time, then you basically inject some nice command into your agent. You get a very good review, although the paper is shit. That's the way of, I don't even know if this do not highlight is actually written by ChatGPT or Claude. That could be the next meta level. But so these are type of things that can basically happen, okay? And so you want to be very, very, very careful that you don't actually have this type of text in your training data or in your any type of AI application downstream. So this gives you a bit of an idea. And so we try to be very well aware of all of these cases. Now, from an application or from a library perspective, essentially what Docling does is how does it deal with all of these formats and how does it try to deal with all of these edge cases and stuff like that? Is we have this concept of pipelines, and what the slide doesn't show is you have a frontal, let's say a door, and in this door there is like a big switch that tries to identify based on the content on the extension of the file, etc., etc. What am I looking at? And then it starts to filter effectively or distribute depending on the format that it has identified to different pipelines. And so this is where we will use different types of AI models. So for example, for audio, we'll use Whisper, for example, one of the models that you can do for transcription. Then you will see here in PDF and images, we now have actually two different pipelines. We have what we call the standard PDF pipeline, that's the bottom one. That's like an ensemble where you run multiple models one after the other. It's way more robust, but of course, as you are running these, and it's slightly faster, as you're running these models, you will accumulate errors, and it's less flexible for very complex layouts. So I still would recommend for most simpler cases, I would run that one. But we have also started to put in like the visual language model pipeline. This is where we're building all the new models, and we hope that we can kind of overtake the standard one. And this is where you can put any of your classical visual language models in. We released already two, like Small Docling and Granite Docling, very recently. They were very successful. But you can plug in your Quens or your Pixel or whatever else you want to do. So that's all up to you. It's just a configuration. And then on the bottom, we have, like I would say, the more programmatic ones, so your DocX, PowerPoint, etc., etc. We basically process that purely programmatic. And ultimately, all of this goes into DoclingDocument so that you essentially have one representation on which you can do all kinds of operations. And this is where we also are adding a lot of capabilities so that you can also edit, you can insert text, delete text, do whatever, iterate over the document, these type of things. And in addition, we also give you the capability to do transformation. So we have automatic chunkers. So you don't have to build chunkers based on, for example, exported Markdown, but you can directly leverage the built-in chunkers that will leverage all of the structure that is there to then just very quickly provide you text chunks that you can then encode essentially. So that's kind of like the whole setup. It's very customizable. So if you want to take one part of the pipeline and change it, then you can do that. And that's kind of what we did with Hugging Face over the summer. So we built actually this fine PDF web data set. And this also gives you, again, an idea of like where we can actually work on. Or where Docling actually shines. So they took all or many PDFs, around 1.4 billion, I believe, from Common Crawl, ran that actually through. Figured out if it was a scan document or a programmatic document. If it was a programmatic document, it went through Docling. If it was a scan document, through one of these VLMs, LlamaOCR. But actually what is interesting is that you can actually do the calculation like per document. You can look at the cost essentially. And because these VLMs are so much more expensive to run compared to that, so we did 3 times more documents. So Docling did 3 times more documents. But the cost was significantly less. I mean, really significantly less, like 20x less. So you end up with like a massive factor of cost. And so we are still a corporation. So when we are talking with big customers that need to do lots of processing, I mean, 50x less cost makes, of course, a huge difference to the bottom line. So these are the kind of things that when we run really at scale makes a huge difference. Having said that, so VLMs are still quite expensive, especially the one, I think LlamaOCR is 8 billion, but they do have like some really cool features because you basically just have to provide the image and it actually can spit out a lot of information. There are a lot of OCR engines or VLM out there. I'm gonna use OCR and VLM a bit through it, but essentially VLM will do both reading order and layout and OCR and tables and all of these things in one shot essentially. The reality is though that most of these are quite big, so they're typically in the 8B. There are some that are 3B, but they're all quite expensive. And so what we do is if we want to run those through Docling, the way we typically do it is we take them, we say, okay, we give in the prompt to do to Markdown and HTML, and then we parse that backend, and then we put it into a Docling document. I must warn, though, that there's a lot of... So the output is typically looks good, doesn't mean that it is good. So you have a Qwen 2.5 3B, it is a new Qwen 3 just out now, so then we'd have to update this one. But basically, I just took one page that looks actually pretty decent. It's not very, very scary. But if you actually carefully look, I don't know, yeah, exactly. So there is that that paragraph all the way on the top with 3 lines, it's just missing. Okay, so this is like one of these cases where in the VLM, so you just run text through, and at first glance it looks like, oh, it's amazing. This looks like why bother with all of this other stuff? And then you realize that this like stuff is missing, and you don't see it very well. So that's not really very nice if you're going to use document processing for people like lawyers, contracts, patents. What could possibly go wrong if you miss a paragraph, right? So this is like the type of thing you don't want to see. And similar, I mean, even Pixel 12b, you know, there is like the table is just wrong. And so it's, if you look at it, if you squint your eyes and you don't look at the content, it looks good. If you start to actually dig, you think, well, okay, this might be not exactly what I want. So we are now on a mission to actually, we do believe VLMs is the future. So there's no doubt about that one. That AI will go there. The question is just when. So we released already early March, our first small Docling. This was our first attempt. But from the start, we go very, very small. So 256 million parameters. And in no time, we were number 1 on Hugging Face. So we told, okay, this kind of starts to make sense. It has a lot of issues in terms of also forgetting stuff. But right now, we're really working on the quality first. And I'll tell you a little bit of ideas later down the road. We just released in September 17 our official Granite Docling. So this was in IBM end-to-end. Small Docling was with Hugging Face, so based on fine-tuned small VLM. That already has, because we put a lot of effort in it, already a lot better performance, raw performance in terms of forgetting stuff and doing wrong things. And you know, I'll come to what we are now going to do later down the road to actually really completely fix that. But that's kind of, those are the 2 models out there. This is the other one is 258, and this is doing pretty well. Now, what is it actually doing in the back end? So it's taking basically images. Actually, maybe I'll start with that one. It basically takes images. It has like a prompt on the bottom. You go through a vision encoder, then you map actually the vision tokens into the language model, and then you let the language model do its thing. And effectively, what we do is we actually encode all of the unstructured document into something that's LLM friendly. So kind of like a XML format, where actually each XML tag is done in such a way that you have a one-to-one mapping to the tokens. So you can really reduce massively the number of tokens. So we're trying to map that into a new ISO standard, essentially, with a lot of variations. And it's kind of complicated if you have stuff that is going across pages. But because we have this nice representation, we already saw that we don't need to have these huge 8B models, but we can actually have a very, very succinct representation and actually squeeze everything into 256 million parameters, 258 million parameter models. And so this gives us some good performance already. So we're comparing with actually the other, this was small Docling still, with the other VLMs, and even the ones that are much, much bigger, like 10 or 20x bigger, we actually get relatively similar performance numbers. So that gave us like already a pretty good vibe. This was for small Docling. We actually, Matteo will fly to Hawaii to present that next week. But that gave us like a good vibe. And so basically then with small Docling, with Granite Docling, we wanted to go one step further. So basically there, we've been working then over the summer to actually train this. And now we're actually having a lot better results, especially on math and encoding and all of these type of things. So that's, I think we're going to get there. Maybe we need to make the model slightly bigger, not much bigger, and train even more. But I think that was pretty much under control. And just to give you a bit of an idea what it actually means, this is actually a demo. I can also do it live, but see, no, that not. Let me do it like this, since I anyway have. So I have it here open. So this is actually the demo space on Hugging Face. And what you can actually see here is, you have different documents. You have a lot of math here in the middle. We can do different types of prompts here, but really what we ultimately focus on is the convert this page to Docling. That's the one that we're really focusing on. All the rest is a nice to have. And if you click on it, okay, then the GPU will start working on it. and then you will still start seeing actually it's spitting out, right? So you have a doc tag, you have a page header, you have the 4 location tokens, so this is basically the bounding box, and then you get basically the text. We try to make sure that maybe you cannot see it very clearly, but all of this math and all of these things comes out perfectly, including also the actual formulas. And so, this is quite a lot of work has gone into actually making sure that we can actually deal with all of that. If it finishes, then it will in the demo it will automatically parse it and put it into a nicer Markdown. So that's definitely something. Yeah. So here you see. So this is now parsed, and then basically you have all of the formulas that are actually coming up nicely. So a lot of work has gone into that one. We've done it for Chinese and for Japanese. So the model can do Japanese, Chinese, also Arabic. Arabic is an interesting one because it goes right to left. So during the visualization, I like to show this one because during the visualization, it seems like it's going bananas. But yeah, it's like printing in a weird way because right to left is a very it's not a very easy thing for HTML. But what is actually nice is that you can do very funny things. We try to put some initial stuff already in charts. So if you want to actually take a chart and convert certain charts to actually tables, then you can also do that. So play around with the demo, but you can of course also directly use it. So this is kind of all the work we're trying to do. There is also a web GPU version of that, so that can actually run completely in your browser. I'm working with Joshua from Hugging Face to actually make sure that like if you want to build applications in your browser, you can actually on the fly in the browser do document conversion. Why you would want to do that, I don't know yet, but I'm sure somebody will come up with a cool application. So I'll leave that to that. So maybe then I want to just jump to a few more things. So we have this data extraction. So far we've talked a lot about data extraction. One of the conversion, one of the interesting things with the data extraction is that quite often in business applications, you might have like invoices and this and that. And so if you then want to quickly get just populating or getting the real data out that you're only the data out that you're interested in, then you can do that. And that's actually why we built this. Few other things. There's Docling MCP. That's for making anything, all type of agents that deal with documents. So we're building a lot of actually example cases there. Pretty soon, I hope I can make an example case for an agent that can start filling out your tax form. So that's kind of what we're working on in the backend. So that's going to be a fun one. We're working a lot with the folks from LangFlow. So this allows you then to actually build pipelines in a low-code, no-code thing. And I'm going to just finish up with one use case that we have been running that is probably a bit more industrial, but that is actually quite, it just tells you at what scale we can also do things. And it's not just that single documents, but a little bit more interesting. And actually quite relevant for Switzerland in terms of the pharma industry. So we are using internally Docling essentially to parse a lot of patterns. And so the funny thing with patterns is that they have a lot of pharma and very high quality or very expensive chemistry industry, and they like to hide the molecules they're finding in images because then you can really not search them, right? So if you put them in text, then you can search who is doing what and who is patenting what. But if you put those molecular images or molecular structures in images, then it's very hard to actually search because they all look alike. So it's not like you can quickly encode them and do whatever. So the reality is that actually if you want to see like who has patented this molecule, it's ultra hard and you pay an enormous amount of money. And so what we've been doing is taking like all the big patent offices, so United States, Japan, China, Korea, and Europe, and actually run them through Docling, find actually where all the images are, then classify them that they're molecular structures, and put them actually in a database so that you can discover them. So essentially what you then do is we have actually this application where you can say like, okay, I'm looking for a molecule that has the following properties. This square there is called a squarelium. And you can then actually find all of the ones that have these squares, and you can see which patterns there are. We cross-correlated that essentially with paid databases. So now you can think like, of course, the Elsevier's, these type of publishing, they have already quite a few people that are manually annotating all of this. And so they're building actually these databases that are fully proprietary. And so essentially we compared them, and as you can actually see, like if you look at, we took 10 random patents and we looked at like, okay, are the molecules in the patent or are they in the proprietary database, are they in our database, etc. And so the yellow is the overlap, and you see actually in the blue is what Patsit kept out, and the red is actually what Reaxis is doing. So we are very complementary, but of course this was already 2 years ago, so that gives you kind of an idea. We'll keep on actually working exactly on this. But it should allow us effectively to, if we really want to build a complete database of all of these molecules, to do that. So that's actually really, you're basically running then on terabytes of documents and analyzing the compounds. And the fun thing is, because we then did that, we then build also some very simplistic agents to start looking at like new types of molecules with, basically you see this squarilium again, and we're trying to figure out what can we actually fit on the squariliums. And so now we have a few very nice, actually new molecules that we discovered because of, basically we look at all the variations, and of course you have a square of things, and then you see actually which ones are actually not yet explored. And so we found a few new use cases or new molecules that that have actually high impact in specific industrial applications. So it gives you an idea like, okay, we are doing document conversion and all of these things, but if you really want to then leverage that in an application to actually discover something new, it's relatively easy to do. And with that, I am done.
Perfect time. Yeah. Good. Yeah. I think we can use the beginning of the lunch break for one quick question. So Timon seems to have one.
First of all, thank you for an interesting talk. I just want to ask, since PDF loses all this semantic structure, is there also an approach for a standard to add this structure back as metadata in the PDF?
Yeah, that's that ISO standard that we're trying to build, yes.
Okay, sorry I missed that then.
No, but that's actually our idea is to first make the ISO standard for the content, and in the PDF there is actually a slash metadata or slash meta, I don't know it by heart, but there you can actually put whatever quote-unquote XML variation in it. So that's already there. The problem is, again, there is no standard for what that actual content should be. So we're now trying to build that standard so that then you could actually do that from the start. Yeah.
Thank you very much.